Hello students, today through this lecture video we will be going to study about the measurement technique of KLA and what are the different methods and their advantages and disadvantages. Before going in detail about the measurement of KLA, let's recap about the KLA. Let's see what actually KLA is. KL is actually a volumetric mass transfer coefficient and it is a combination of two terms KL and A. KL is mass transfer coefficient and A is the gas liquid interfacial area. KL is also called as reciprocal of sum of resistance faced by oxygen molecule for dissolution into the liquid medium. When we write KL and A together, it is called a volumetric mass transfer coefficient. And now let's see what is the significance of KLA with respect to the bioreactor. Actually, the KLA measures the aeration capacity of a bioreactor. Now, we have seen what is KLA and what is its significance. Now, the most important part comes is the determination of KLA. How we are going to measure KLA into a fermenter or bioreactor. So before going in detail about the answer why it is necessary to measure KLA in bioreactor or fermenter. The reasons are very simple. There are basically two reasons. First one is to measure the aeration capacity of the bioreactor, and second to quantify the effect of process variable. Process variable here refers to pH, aeration speed, agitation on dissolution of O2. We have seen till now we have seen about different methods and what are its significance and what are KLA. Now let's see what are the methods available for measurement of KLA in bioreactor. Basically there are three methods that we normally use for measurement of KLA in bioreactor. First one is the sulphite oxidation method. Second one is the gassing out technique. Gassing out technique is further divided into dynamic gassing out technique and static gassing out technique. And third one is the oxygen balance method. These three methods are basically the backbone for measurement of KLA, and these all three methods have certain advantage and disadvantage over other. So first method of KLA determination is sulphite oxidation technique. Let's see what is sulphite oxidation technique. It is basically an indirect technique where rate of oxygen transfer is measured in an aerated vessel. It uses rate of conversion of 0.5 molar sodium sulphide solution to sodium sulphate solution in the presence of copper or cobalt catalyst. The rate of oxygen is such that as soon it enters in reactor, it is immediately consumed by sodium sulphite and get converted into sodium sulphate. It means as soon as the O2 enters into the reactor, the sodium sulphide gets oxidized into sodium sulphate. So here let's see, sulphide oxidation rate is equivalent to the oxygen transfer rate. Therefore, dissolved oxygen concentration basically will be 0. Let's see why it is 0. Because we are assuming that as soon as oxygen enters into the reactor, the sodium sulphide consume this oxygen and get converted into sodium sulphate, and no oxygen is left for dissolution into the culture media. So according to the KLA equation, dCl by dt is equal to KLA into C star minus Cl equation. Here we are assuming that DO concentration is 0, the Cl term will be 0. Therefore, oxygen transfer rate will be just simply the product of volumetric mass transfer into C star. So we have seen this is a method of sodium sulphide oxidation where we are using 0.5 molar sodium sulphide conversion to sodium sulphate, and we are measuring oxygen transfer rate indirectly. Now, let's see what is the advantage and disadvantage of this technique. So first one is advantage. Advantage, it is extremely simple and very inexpensive. But Disadvantage is that it does not give you the correct KLA value, and it gives always higher KLA value compared to other method like gassing out technique or oxygen balance technique. And third one, it is time consuming. Why time consuming? Time consuming in this regard, like we have to, each time we have to take out the sample from the bioreactor and do the titration and then plot the graph, and these are very time consuming and tedious. The second method of KLA determination is gassing out technique. Let's see what is gassing out technique. Gassing out technique actually measures the rate of increase of oxygen with aeration. It has two variants. First one is the static gassing out technique and second one is the dynamic gassing out technique. First we will see about the static gassing out technique. Why it is called static? Let's see why it is called static. It is called static because we are not using actively respiring culture. It means your culture media does not have any microorganism in it. We are not considering its respiration of microorganism. That's why it is called static gassing out technique. Now let's see how it is done. This method is basically a combination of two steps. Step one is the deoxygenation of culture media by bubbling nitrogen into it, and second one is the reoxygenation step, which involves a supply of air into the oxygenated media and noting the rate of increase of dissolved oxygen concentration with time. The dissolved oxygen concentration is measured with the help of dissolved oxygen probe. So what we have seen till now that static gassing out does not involve microorganism, and second, it is a combination of two steps, oxygenation and reoxygenation, and the rate of increase of dissolved oxygen after the deoxygenation step is monitored using dissolved oxygen probe. So as we know that the rate of increase in oxygen concentration is given by dCl by dt KLA C star minus Cl. When we rearrange it and re-separate this variable and integrate it, we find the relation ln C star minus Cl is equal to minus KLA into T. By plotting a graph between ln C star minus Cl versus T, we will get the value of KLA. The slope of that plot will give the value of KLA. The second method in gassing out technique is the dynamic gassing out technique. So let's start why we are calling it dynamic gassing out technique, because we are not using any inert gas like nitrogen for scrubbing the O2 from the liquid media or fermentation media. Here we are using actively growing and respiring microbial culture for decreasing the O2 concentration. Let's see how the actively growing microorganism decreases the O2 concentration and what are the steps in dynamic gassing out technique. For measuring the KLA using dynamic gassing out technique, what we do, at a certain point in fermentation, during fermentation, we switch off the air supply. When the air supply is switched off, the actively growing microorganism use up the dissolved oxygen that is dissolved into the liquid or fermentation media, and slowly the DO concentration level goes down, and just above the C star critical oxygen concentration, we switch off the air supply once again. The air start bubbling into the fermenter and the dissolved oxygen concentration start increasing, and we measure the increase in dissolved oxygen concentration with time, and at a certain time the dissolved oxygen concentration achieves a steady state. We have seen two methods of KLa determination. First one is the sulphite oxidation method and second one is the gassing out technique. Now let's see the third method. Third method is the oxygen balance method. Now, as the name suggests, we have to balance oxygen. In balance method, what we do is we balance the concentration of oxygen in the inlet stream and the concentration of oxygen in the outlet stream of the reactor. The difference is between the inlet and outlet stream we consider is the oxygen that is dissolved into the bioreactor. So we have to just use the mass balance under steady state. The difference in oxygen flow between inlet and outlet must be equal to the rate of oxygen transfer from gas to the liquid. So this method is extremely very simple and it gives accurate value of KLa, and one of the biggest advantages of this method is that it can be applied during the normal bioreactor operation. How? So during the normal operation, what we do is we already know the concentration of air what we are sparking into the bioreactor, and by using suitable outlet vent we can measure the oxygen which are exiting the bioreactor, and then balance both the concentration, we will get our KLa value. The difference between the inlet and outlet is actually the dissolved oxygen concentration.